Nice to meet you. I'm Khadar Choktai and you're watching my YouTube channel School of Advanced Chemistry. I'm going to explain ATP 5070 O-Level Chemistry October November 42 variant. Let's get started. Paper 4 alternative to practical, time 1 hour and total marks is equal to 40. Come towards question number 1. All students investigates the electrolysis of concentrated aqueous sodium chloride. Figure 1.1 shows the apparatus the student uses. And here is the beaker having concentrated aqueous sodium chloride, 2 graphite electrodes, and what is this apparatus X he is asking, I think. And here is the collection of chlorine, and obviously there will be the collection of hydrogen overall. There will be the collection of H2. Now come towards option A, name apparatus X, that is inverted test tube. Basically, generally it is said to be test tube. Part B, give a reason why the iron electrodes are not used during this electrolysis. Basically, it may react with the product. It may react with the product formed as it is non-inert electrode. So that's why it cannot be used. Part C, chlorine gas is produced at the anode during this electrolysis. Describe and explain 1 safety precautions the student takes during this electrolysis. Number 1, what are the safety precautions? You know, the chlorine gas is basically said to be the toxic gas. Toxic gas if it is taken in a plentiful amount. So generally, whenever you are going to talk about the safety precautions, then especially in case of nitrogen oxides, especially NO2, in case of SO2, in case of carbon monoxide, in case of Cl2, these are supposed to be toxic gases. So in all these gases, in case of Cl2, in case of NO2, in case of formation of SO2, in case of expulsion of carbon monoxide, the safety precaution is basically fume cupboard. Fume cupboard. Or you can also use the ventilated room or ventilated place. But the reason behind it, as I told you, these all are basically supposed to be the toxic gases. It's toxic gas. Part D, a different gas is produced at cathode during this electrolysis. Name the gas produced. Describe a test and its result to confirm the identity of the gas. Name of the gas and description of the test and result. So what is being formed at cathode? In this case, as I told you, basically hydrogen gas is being formed as it is having 2 positive ions. Sodium positive ion from this NaCl and H positive ion from water. So there is competition between 2 ions, sodium ion and H positive ion. The winner is H positive ion. It will go towards cathode and it will change itself into hydrogen gas. So what is the basic procedure to check it? Number 1, name of the gas, that is hydrogen gas. And the procedure is basically introduce lighted splint. Introduce a lighted splint and pop sound will be observed. So pop sound, or you can also write squeaky sound. So that is a test of hydrogen gas, and that's all about question number 1. That was basically from Electrolysis chapter number 4. Question number 2, sulfuric acid H2SO4 is neutralized when it is added to aqueous sodium hydroxide. 1 mole of H2SO4 is going to react with 2 mole of sodium hydroxide to make 1 mole of sodium sulfate and 2 mole of H2O. The reaction is exothermic. P is 1.25 mole per dm cube aqueous sodium hydroxide. Q is dilute sulfuric acid. A student determines the concentration of sulfuric acid in Q. The student does 6 experiments. Here are different steps. Step number 1. Step 1 uses a volumetric pipette to add 25 centimeter cube of P to the plastic cup. Step 2 uses measuring cylinder to add 20 centimeter cube distilled water to the plastic cup. State the mixture in a cup with a thermometer and record its temperature to the nearest 0.5 degrees Celsius. Step 4, use a burette to add 5 centimeter cube of Q into the plastic cup and stills. Record the highest temperature reached. Step 6, empties the plastic cup and rinse it with water. Step 7, repeat steps 1 to 6 using 5 different volume of distilled water and Q so that total volume in the cup is always 50 centimeter cube. Student results are in the table 2.1 and this is the table 2.1. A. Complete table 2.1 by filling in 3 missing values. In first row, the temperature rise is missing. This is initial temperature, this is the final temperature, and what is basically changed 25.5 minus 23.0, so that is equal to 2.5 degrees Celsius rise. Then in this third row, total volume of the solution must be equal to 50 as you have seen it over here in this case, and here 25 is P, water is 10, then obviously the rest of will be the Q, so it is 15 centimeter cube to make sum equal to 50. In this case, experiment 6, once again the sum of the solution must be equal to 50, so these 3 are the major constituents of the solution, and it's 25, it's also 25, so there will be no any volume of water. Now come to the next portion. Part of the thermometer used in experiment 3 are shown in figure 2.1. The liquid level inside the thermometer are missing. Complete figure 2.1 by drawing in the liquid level to show the initial temperature of the experiment 3 and the highest temperature reached in experiment 3. So in experiment 3, what is the initial temperature? Here is the initial temperature and this one is 25 degrees Celsius. So it should be over here 25 degrees Celsius, and in case of its highest temperature 3, that is 32.5, and more than 32, less than 33, I mean roughly that is equal to 32.5. Now draw the graph of the temperature rise against the volume of Q on the grid figure 2.2. You should plot the point 00 as there is no temperature rise where no Q is added. Plot the temperature rise and volume of the Q from table 2.1. Draw a straight line for the best fit for the first 4 points. Draw a straight line for the best fit for the last 3 points. 4 points are making one trend and the 3 points are going to form a different trend, you can say. Extend this line so they intersect. So 0, 0 is over here and we are going to start from Q, that is equal to 5 centimeter cube, and here is the rise is 2.5. So 5 and the rise is equal to 2.5. So So 2.55, and here is the 2.5 middle of this block, this box. What is the value over here in case of 10, 15 and so on? So at the 10 it's 5, it's completely 5. Similarly, what is the value at 15? It's 7.5. At 15 it's 7.52, and this is a 7.5 rise in temperature. Then 18, 20, 25. What over here is basically, here 10 is equal to basically 5, or 5 is equal to 10, you can say, and one box is equal to 5 over 10, that is equal to half, 0.5. So half mean half plus 1, 1. So here is the 18. Here is 18. And what will be the answer at 18? It will be 8. It will be 8. So at 18, there is 8. At 18. Now the next thing is, what is the next volume of the Q? That is 20, and it's again 8. 20, and it's again at 8. And the next one at 25, again it's 8. 25, and it's again at 8. You can see that it's a 25 and it's 8. So there are basically two lines, 3 points lines, and here are basically, you can say, the 4 points lines. So this is 0, 0 basically. Here is the 0, 0, and these are the 4 points, and here there are 3 points. So we can extend these points. If I'm starting from here, so I can extend this line through these points like that. And same is the case if I'm starting from this line, that is going to extend okay. So now this is the point of intersection, and again we can mark a line over here to find the volume used. So it's roughly equal to 16.25, you can say. It's maybe 16.25. The point where the two lines intersect indicate the volume of the Q that exactly neutralizes 25 centimeter cube of P. Determine the volume of the Q where the two lines of the graph intersect, that is 16.25 according to my this you can see the rough calculation that has been made on this laptop. So what is the next one? P is 1.25 mole per dm cube aqueous sodium hydroxide. Use your answer to D. Calculate the concentration of sulfuric acid in Q. You know that we have calculated the volume of Q, and here we can find its concentration. As you know, what is the concentration of sodium hydroxide? The concentration of sodium hydroxide is equal to 1.25. Here is mole of sodium hydroxide. Here is the mole of sulfuric acid, and here is the volume of sulfuric acid. So I'm going to use the formula that is C1 multiplied by V1 over N1 is equal to C2 multiplied by V2 over N2. Whenever you are having two volumes or two concentrations, and if you're having two concentration, one volume, or two volume and one concentration, then you can apply this formula. This time I'm supposed to find the value of concentration of Q. Let's suppose this is the concentration of Q. This portion is for acid and this portion is for alkali. So what is the concentration of acid that is to be counted and calculated? I'm going to write it over here. C1 multiply by what is the volume of the acid? That is 16.25. What is the number of mole of the acid from the balanced chemical equation? That is N1 is equal to 1. What is the concentration of sodium hydroxide alkali? That is 1.25. 1.25 multiply by what is its volume? Its volume was taken basically 25 centimeter cube. So it is 25 centimeter cube. Divide by what is the value of N2? That is 2. So I'm going to write 2 over here. So C1 is equal to 1.25 into 25 divided by 16.25 into 2, and this is the concentration of acid. 1.25 into multiply by 25, that is equal to 31.25, and divided by 16.25 multiply by 2, that is equal to 32.5. So what is the final answer? 31.25 divided by 32.5, and the answer is 0.96 mole per dm cube. That is the concentration of acid. F. Describe and explain what happened to the gradient of the straight line for the first 4 points on the curve if the metal cup is used instead of plastic cup. In this experiment you have seen that we have used the plastic cup. For insulation purpose we have used the plastic cup, but this time we are not using the plastic cup, we are using the metal cup. So definitely some of the heat, it may be lost toward the surrounding, so definitely there will be change in the portion of that straight line. This straight line it will be changed, and how it will be changed exactly, the temperature rise that will be noted will be less than that of this one, so it will be less steeper. It will be less steeper, or its gradient will be less steeper. Will be less steeper or less steep. Its gradient will be less steep. And what is the reason behind it? As I told you, some of the energy or more energy will be transferred to the surrounding. Some energy, some heat energy, you can write, heat energy will that will transfer to the surrounding, to outside that cup, to the surrounding. Come to our next G. A burette may be used instead measuring cylinder to measure the volume of water in 3 experiments. As you know, burette is the most accurate, most precise, basically the basic word is precise. It's the most precise equipment to measure the liquid. Suggest how this improves the experiment. The appropriate word is precision basically. So there will be more precision. Next is state the dependent variable in this set of experiment. Basically, dependent variable is the consequences of the other things that we are going to change. And in this experiment, what is changing basically? There is change in rise in temperature. So the temperature rise is the independent variable. And what are the dependent variable? Dependent variable are the nature of basically are the volume of sodium hydroxide and sulfuric acid. These two, quantity of these two or mole of these two substances are said to be independent variable that we are going to change by ourselves. In these three columns you have seen that. But what is the result? The result is this one. By changing their different volume, by using their different volume, basically especially the volume of the Q, as we are changing the volume of the Q. So the volume of the Q or the quantity of the Q is independent variable, and its consequences, its result, that is rise in temperature, it's said to be dependent variable. So dependent variable is rise in temperature. Rise in temperature. That's all about question number 2. Question 3. A student investigates solid Y and solution Z. A. Solid Y is a white and contains carbonate ion. I mean, it's a white solid, and it's a white, so it is not having any transition metal. The second thing is it's containing carbonate ions. The test student does on Y are shown in table 3.1. Some of the observations for these tests are also shown over here. So table 3.1, number 1, add excess dilute sulfuric acid, excess to add to Y in the test tube, effervescence, solid disappear. Okay, fine. Then 2, add sodium hydroxide to the solution from test 1 until a change is seen, white precipitate is formed. 3, add more sodium hydroxide to the mixture from the test 2 until further change is seen, white precipitates dissolve. So what is this one? Number 1, predict the identity of the gas produced in test 1. Describe how the student tests the gas to confirm its identity. Whenever you are going to add sulfuric acid or any other acid to the carbonate ion solution, or the solution that is having carbonate ion, so there will be effervescence. That means CO2, carbon dioxide gas, is going to be formed. CO2 gas is being formed in this case. And what is the test for CO2? The CO2, it turns lime water milky. When it is passed through the lime water, it turns lime water milky. Next one. The solution produced in test 1 contains an anion. Name the reagent that reacts with this anion to form the white precipitate when added to the solution produced in test 1 after addition of dilute nitric acid. So it can be help out. You can help out from the pages. Those are given at the bottom of this paper over here. So at the moment we are going to talk about the test of anions and test of cation. So what should be added in this case? What should be the any compound that is going to react with the negative ions and it's going to make white precipitate. You have seen that we are having sulfate ion. So to change into white precipitate, we need a dilute nitric acid. Yes, he has given us the dilute nitric acid. And the next thing is barium nitrate. So the answer is, that is basically very easy and it can be chosen from this page, and it is barium nitrate. It's barium, name of the reagent, so it's barium nitrate. It's barium 2 nitrate or barium nitrate and so on. The next thing, observation for the test 3 are incomplete. State one other observation the student made in test 3. So what is the other observation in test 3 basically? Test 3, add more sodium hydroxide to the mixture from test 2 until further changes seen. White precipitate dissolved. So the next thing is, when the precipitate is going to dissolve, then we will have to mention the color of the solution. So in this case, as there is a non-transition element, so colorless solution will be obtained. Colorless solution will obtain. So colorless solution, or it will be the colored solution, it is going to depend upon the nature of the metal ion that is present over here. As he told us, this is a white solid basically, so it's a non-transition element. So if the precipitate is going to dissolve or is supposed to dissolve, then it means that the colorless solution will be obtained. Will be obtained, you can write it like that. Okay, now come to the next one. Yes, I mean colorless solution will be formed or will be obtained. Next one, fourth portion, solid Y contains only one cation. The student cannot identify the cation from the observation in table 3.1. Use a table 3.1 to name the two cations which could be present in Y. So basically, here is the formation of positive ion by checking the test 2 and test 3. Initially, there was formation of white precipitate, then white precipitate dissolved. So there may be the possibility of two positive ion. One is the aluminium positive ion, aluminium 3 positive ion, and other it may be zinc 2 positive ion. These two positive ion show similar behavior with sodium hydroxide. Once again, we can confirm it from this data table here. Where is the test for cations? Here. You can see that in case of aluminium, white precipitate formed, and it's formed and is giving colorless solution. In this case, white precipitate form soluble in excess, giving colorless solution. So again, as I told you, these two are going to give the same observation with the sodium hydroxide, but yes, they are not going to give the same observation with the aqueous ammonia. In this case, it remains insoluble in aqueous ammonia, but zinc again, it remains soluble in excess ammonia. So, it's aluminium ion or zinc ion. So, maybe aluminium 3 positive ion aqueous, or there may be the presence of zinc 2 positive ion. Not aqueous in this Y, he is asking in Y, so aluminium 3 positive ion and zinc 2 positive ion. Next one, 5, describe an additional test the student does on a solution placed in test 1 to identify the cation. As I told you, then we will add aqueous ammonia into both sample. If it's soluble in excess ammonia, excess NH3 ammonia, then it is zinc, it is having zinc 2 positive ion. Otherwise, it's having aluminium 3 positive ion, and so on. B. Solution C contains one cation and one anion. The cation contains two nonmetals. So basic thing is there are two nonmetals are making a cation. This is the basic clue. So which one cation is present that is having two nonmetals, that is NH, two nonmetals, NH4, and it is having positive charge, and it is said to be ammonium ion. You can confirm, you can see it from the end page of this paper, the scheme of this paper that's lying over here, and here it is. This one cation, the only cation in this list that is having two non-metals. So ammonia is going to be produced. When it is going to be produced, basically when we add sodium hydroxide. Then how to confirm that ammonia is being formed, then we will perform this test. So I'm going to write number one. Number one, we will write add sodium hydroxide. Number one. Number two, ammonia is going to be formed. A gas is going to be formed, and gas will be tested with a litmus paper. So let's see how to report the answer. The student adds aqueous sodium hydroxide to Z in a boiling tube. Describe how the student completed this test to identify cation in Z. So basically, in this case, first of all, you will heat, warm or boil the mixture. You will heat the mixture. Number one, you will heat the mixture. Then if any gas that is being formed over here, we will test it. Test the gas with the litmus paper. If it is acidic or the basic gas, yes. And if the ammonia is being formed, then it will turns gas, turns red litmus paper blue. Litmus paper blue. So it's of 3 marks. So 3 main portions of the answer should be there. Heat the mixture and introduce the litmus paper, test the gas that is being formed, and the gas will turn red litmus paper to blue and so on. Second part, B. Student adds dilute nitric acid and then aqueous silver nitrate to Z. A precipitate is formed. It is difficult to tell the precipitate is white or creamy in color. Describe how the student uses separate aqueous solution of the chloride and bromide to decide the color of the precipitate. So, test the separate solution with silver nitrate and nitric acid. Test a separate solution with AgNO3 plus HNO3, silver nitrate. Number one. Then you will obtain the different precipitates, right? Compare the color of precipitate. Compare the colors of precipitate. If it's white or anyone white, if in case of white, in case of white precipitate, it belongs to chlorine negative ion, and in case of cream precipitate, it's going to belong, and that is because of the Br negative ion. Question number 3, the next part, the part 3, student adds dilute nitric acid and then aqueous barium nitrate to the Z. Predict the expected observation. So what is the observation over here if he is adding add dilute nitric acid and then barium nitrate? As you have seen that there is no any sort of SO3. Barium nitrate give the precipitate or give the observation with the sulfate ion or with the SO3 negative ion. So in this case there will be no observation, no change no precipitate form, and so on. No precipitate form, and so on. Question number 4. Copper 2 sulfate is a salt used to kill pests on plant leaves. Copper 2 sulfate is prepared by neutralizing dilute sulfuric acid with solid copper 2 oxide. Plan an experiment to prepare pure dry crystals of copper 2 sulfate. Your plan should include the use of common laboratory apparatus, dilute sulfuric acid, solid copper 2 oxide. No other chemical should be used. Your plan should include number 1, apparatus needed, number 2, method to be used. You may draw a diagram to help answer the question. So basically, this is the main points of this planning. So we will use school, college laboratory apparatus, dilute sulfuric acid, and we are given solid copper 2 oxide. No other chemical is allowed to use. And what is the style of planning or the arrangement of the planning? Number 1, we will explain the apparatus that is needed, then the method that is to be used. So first of all, I'm going to write the school, common, college procedure. So first of all, I'm going to write the list of apparatus. There must be beaker, and there may be use of Bunsen burner. And we are using the solid copper oxide that is used to be in excess. There may be the use of measuring balance and stirrer, beaker, Bunsen burner, balance, stirrer for the proper shaking, and filtration, that is the filter paper. That is a filter paper. So first of all, add dilute sulfuric acid H2SO4 into a beaker. Heat it and stir it first. Then excess CuO, copper 2 oxide, then we will add excess CuO, copper 2 oxide, into beaker. Again stir it and stir it again till complete reaction, you can say. Complete reaction. You can say that there are basically two major points. I have wrote it over here. Then number 1, add this liquid, that is H2SO4, dilute sulfuric acid, heat it, stir it. Then I'm going to add copper 2 oxide into that beaker, into that sulfuric acid. Again, I'm going to stir it to ensure the completion of the reaction. What then I will do, I will filter it out. Filter the excess or unreacted CuO from the solution. Right. Then we will evaporate the solution. Rate the solution. I mean filtrate, basically the proper word is filtrate. Evaporate the filtrate or heat the filtrate. You can say, you can write over here, heat the filtrate. Heat the filtrate or heat the solution to make it saturated solution. Heat the solution to make it saturated. Then 4, after the point of saturation, you will cool it. Cool the solution. Cool the filtrate, I mean filtrate solution. And again, filter it to separate the crystal. Filter it. Let me change one thing. Cool the filtrate and cool the filtrate till crystals are formed. Till crystals are formed. Crystals till crystals are formed. Then next one step is again filter it out. Filter out, and this time preserve the crystals. Preserve the crystals. And the last one is wash and dry. Wash with minimum cold water. Cold water. And wash it with minimum cold water. So cold water. Then dry it. Then dry the crystals. And so on. So basically that is the basic main procedure to make the pure dry crystals of copper 2 sulfate. Anhydrous copper 2 sulfate crystals are supposed to be formed. So these are the basically main step. Here I wrote the apparatus, list of apparatus, and then I wrote the procedure. Almost with the 7 bullets. You can change the number of bullets with your own desire, but that is the main script that should be written over here. That's all about this paper, this ATP. Please subscribe my channel, hit the bell icon and share it with your friends. Thank you very much. Have a nice day.